Okay, so let's resume that. So we were discussing about the electric charges, and we discussed that electric charge is a physical quantity which can be measured. So electric charges can be measured in the SI unit of coulomb, in the honor of the great French physicist Charles Augustin Coulomb, who who elaborated the studies of the interaction of electric charges. And there are other units of electric charge as well, right? Like stat coulomb or EMU, Faraday, etc. So, moving ahead, now we have to discuss the general properties of charges which are important for us. So one of the most important properties of charges are conserved. That means charges can neither be created nor be destroyed. It can just be transferred from one body to the other body in such a way that the net sum of the charges remain constant. The other important properties of charges is that electric charges remain quantized. That means the charges can always be found in the integral steps of a certain magnitude of charge, and incidentally this is the same magnitude of charge which is generally found either on electron or the proton in the free state. So charges in the free state are always quantized, although we have an exception to this rule, that charges are found in fractional unit, and this association of fractional unit of charges is there with quarks, but quarks are not found in the free states. In free states, charges are always found quantized. They're always found in the integral units of E, that is Q is equal to plus minus n times E, where E is equal to 1.6 into 10 to the power minus 19 coulomb. So based on these two properties, that charges are conserved and charges are quantized, let's solve a question. We have a tradition of taking numericals to have a better understanding of the physical concept. So let's take two bodies, A and B, in such a way that A and B have been rubbed together, for example, and after rubbing, the body A has been observed to have found has been observed to have associated a charge plus Q, and the body B is observed to have a charge of minus 32 coulomb. That means some amount of electrons would have transferred from body A to body B, actually. So applying the principle of conservation of charges and principle of quantization of charges, we have to find what is the value of the positive charge over A, and what is the value of number of electron which have been transferred from body A to body B. So from the principle of conservation of charges, we can rightly identify that plus Q is equal to plus 32 coulomb, because minus 32 coulomb has been found over B. And then we can apply the principle of quantization of charge using Q is equal to plus minus NA into E. So solving out, so N is found to be 2 into 10 to the power 20 electrons. So this way we can find what is the number of electrons which has been transferred from A to B, and what is the charge which has been observed over A.